students, this is Mrs. Moore, and it's Sunday, and I'm making my own edpuzzle, so I'm trying the best I can. This week, you have a choice. You have to do the one edpuzzle, the crash course, and it's going to talk about the convection current rising and sinking, and it's a density current. Then you have a choice between this video and the other one, which is on the saltwater density current. So if you want to do extra credit, you can do both. But this video is going to be on the density current, changing the density of water. And what I'm going to do is I'm going to take oil, and you've seen this before. I've showed it to you, but I'm going to stop and ask lots of questions. Like oil first, I will put the same amount of oil. I'm going to put 50 milliliters. Oh, you know what? I think that might be too much. I'm only going to put about, let's see here. Oh, that's a good 25 milliliters. And I'm going to get 25 milliliters of, yeah, I'm pretty good with that. Look, they're about the same. Yay, they're about the same. They're little different size containers, but I should usually do the same. But I'm at home, so I got to use what I have. So we're at about 25 milliliters each. Now I know that water is more dense than the oil, so I'm going to put the water in the bottom. Okay, I'm not going to put as much water. There we go. And I'll put the oil on top. We should have an equal amount. Yeah, I did pretty good. Woohoo! I'll tap it a little bit. Tap, 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 tap. Now I'm going to set it here in my glass container so you can see it. I'll move it up a little bit. I'm going to take my 1 drop of food coloring. And we've done this before, green. It's at my house. We have left from Christmas. And I let it drop. It's coated in the oil so it stays there. Its density is stuck there until that oil breaks in the water. And then it's going to be the same density as the water. Kind of neat how that works. I'm tapping it so it goes down a little bit. And it's fine right there. The oil has a density, a number, 0.93 grams per milliliter. And you could also say grams per centimeters cubed as well, because 1 milliliter and 1 gram per centimeter cubed are exactly the same thing in water only. Okay, so we got that little drop of food coloring stuck in there. Now, this is one of the 2 experiments you can do this week. There is a paper to fill out. You can take my demonstration here and complete the paper, or you can come to class if you are one of the A or the B people, and you can come to class and say, okay, Mrs. Moore, I'm going to do this experiment and collect my own data. Perfectly fine. If you are somebody who wants to do it to see it yourself, that's what I want to see happen. If you're somebody who's at home, you have 2 choices. You can use this video to answer the lab, or you could ask me nicely, Mrs. Moore, can you get the materials ready for me? I'll send you a plastic cup. I'll send you, a denture tab and some information. You're going to have to supply the oil and the water. And if you have food coloring, great. If you don't, that's not a big deal either. Now, the oil is on the top. The water is on the bottom. And one of the best things to do for this is actually to have a light through it because you can see it much better. And I don't tend to have a light around here. No, I don't really. But I'm going to drop, this is a denture tab. And we talked about this before, and I made you guys guess, but I'm going to exactly tell you. This has carbon dioxide in it. Carbon dioxide is 0.004% of our atmosphere. It's not much, but carbon dioxide has this ability, carbon actually, absorbing heat and not releasing it, which we have a balance on our planet right now between energy that comes from the sun and energy that we hold and release. And we're in a balance. And that balance is keeping us at the right temperature for human life and life that we have today. However, if we have more carbon, it will get warmer. If we have less carbon, it's going to be colder. Now, our planet has had more carbon in the atmosphere. It has had less carbon in the atmosphere. There's a fluctuating pattern, but we have to be careful that we're not going to increase or decrease the natural cycle of our planet Earth. Just a side note. I'm going to drop this in. The carbon dioxide, okay, there it goes. Got to drop down. There we go. The carbon dioxide is a gas, and it's going to change the density of the water. And there you see it goes up. The density of the water is going to become less dense than 0.93 grams per milliliter, and it's going to go to the top. And you see it, it's filling up at the top. And all of a sudden, oh, there goes one down. That's because the gas at the top released. And the water no longer had the gas and it became more dense. Therefore, it drops. Now, this density current is also called the convection current. This is taking place very slowly in our mantle as a result of the heat from the Earth's surface, the original surface, because of the friction, because of the gravity, and because of different radioactive elements. But a slow process of this current is currently shifting our plates. We used to have Pangea, one large landmass, but now we're separated and we're continuing to separate. The atmosphere is very similar to this current. Our planet is round, and the direct sunlights hit at the equator, which heat the water and the land, which then re-radiate. Love that word. I'm being sarcastic. Re-radiate. It just doesn't sound pleasant, but it does. The ground and the water heat the air directly above it. And that is why the troposphere, the lowest layer of our atmosphere, tends to be the warmest. And then as it warms, it rises, just like what we have here. It gets so high and then it cools. A lot of times when it gets high up in the air, it starts to condense and cause any humidity in the air to fall down. This is so very important. It's the convection current. So not only does it happen to cause plate tectonics, it also happens to cause weather. Now get this. Our currents in the ocean are also a result of the convection current. Warm water at the equator is moving, and the cold water fills in, creates worldwide water current patterns, which in turn also heat and cool the air, which in turn affects the atmosphere. We got four things going on constantly. We got life, the biosphere. We got land, the lithosphere. We've got the water, the hydrosphere, and we've got the air, the atmosphere. These four things are constantly affected by this density current and by you and I. Okay, that's all she wrote. I have a few questions. Make sure you get them answered. Best of luck on the lab.